Imagine this: someone on the internet is trying thousands of passwords to break into your company's system. Another attacker login through RDP and quietly moves through your network. And suddenly, a user account logs in from two different countries within a minute. Login success from Australia and from USA. So these are not movie scenarios. These are real SOC alerts happening every day. And today we are going to learn how to detect them. All right, so welcome back to day 36 of our 100 days in SOC journey. And today we are diving into three super important real world use cases. So the number one is brute force. Brute force. Number two, RDP abuse. And number three, suspicious login. So by end of this video, you will learn what these attacks look like, what logs SOC analyst actually monitor, how to write detection queries, and most importantly, how to investigate them like a pro. Let's get into it. All right, so the use case number one, the brute force attack. So a brute force attack is exactly what it sounds like. An attacker keep trying many different passwords until one finally works. So why does matter? So brute force attacks are very dangerous because they are often the first step of the bigger attack. So they are the first step of bigger attack. So once attacker get access, they can move across your network. So they can log in on one machine, go on the second or third or fourth. So this is a classic lateral movement. So they can move and then they can escalate privilege escalation, and they can deploy the ransomware or steal sensitive data. So attacker can move across your network, they can escalate privilege, they can deploy ransomware or some data theft. When investigating brute force attempt, SOC analysts usually check the Windows logs. So Windows security log, especially the 4625, the 4625 is for failed login, and also the VPN logs, and also web server log, especially the 401 errors, and firewall and IPS logs. So 4625 is very important from failed login or brute force perspective. So these events mean failed login attempt. So if you see multiple 4625, that means it's a brute force. Then the detection logic. So the detection logic is very simple. If a user or IP address generates Many failed login attempt in a short period of time. So something suspicious might be happening. And what query you can write? So you can write some detection query. So here is the basic query that you can write. So for a Splunk, you can write index equal to Windows, and then event code equal to 4625, and then pipe states found by user and source IP, and then another filter here where count is greater than 10. So Windows event code 4625, count by user and source IP, and then count is 10. Then KQL. So KQL, we can start with the security event table, and then pipe where event ID equal to 4625, and then summarize count by account, IP address, and also we can use some bin here. So bin time generated and 5 minute, and then another filter where failed login attempts more than 10. So this is a group of failed login within 5 minutes and flag high activity. So this is how you can write SPL query and KQL query. Now let's talk about the investigation step. So when you see this alert, here is what a SOC analyst usually check. So you can check, did the login eventually succeed? So login succeed, and what IP is involved. So IP address, and is the location unusual? Did the user start accessing multiple system after login? So check for the lateral movement. So this is what you can check after getting the alert. Also, you can create a query for password spray. So instead of trying many password for one user, attacker try one password across many users. So this is what we can create to detect these kind of attack. All right. So the next use case we have. So RDP or remote desktop protocol is a legitimate tool. Who use it? So admins use it for remotely manage system, remotely manage system, manage remotely. But attackers love RDP for three reasons. So attackers also love RDP because they can also remotely manage. So it give them full graphical access, so they can get the graphical access of the system. And many companies leave it exposed on internet. So many companies leave it exposed on 3389. And the third reason we have, it is sometime poorly monitored. So this is poorly monitored. So that's why attacker loves RDP. And why it is matters. So in many ransomware attack, the attackers first gain access, then log in into system using RDP to move around the network. So suppose if attackers got the access using brute force on the system, so they try RDP to log in on the multiple systems. So this could be from one system, or this could be from second system to third system, or third to fourth. So this is called nested RDP. And what logs we can monitor? So logs we can monitor, it's like Windows security log, and also firewall logs, network traffic log, and also if the sysmon is deployed, then sysmon logs. And what important event ID we can monitor? So we can monitor the event ID 4624 for successful login, and then we can check the logon type 10, which means the RDP login. So this is called remote interactive login. Okay, and what Splunk query we can create to detect this kind of attack? So we can write a query like this. We can start with index equal to Windows, and then event code 4624, and then logon type equal to 10, states count by user, source IP, and then computer name. And also, if you want to detect advanced attack, then you can apply a filter where count greater than 5. If you enable it for 1, then it will be flooded, like normal activity will also considered here. So this is SPL, and also similarly we can write a KQL, but I'm not going to write it. So investigation checklist. So when you are investigating suspicious RDP activity, ask these questions. So is the IP internal or external? IP internal or external? Does the user normally use RDP? So it's a regular activity or rare activity. So just check it for the user. And then what actions happened after login? So you need to go in the timeline and check. So monitor actions. So if you see any suspicious action like removing the file or accessing the file or deleting the file, then it is a signal of clear attack. And then were file transferred? So check for the file transfer activity, and also see if any scheduled task created. Scheduled task created. All right, and what are the tips? So you can check the PowerShell.exe, and also new user created, scheduled task, service installation. So this help detect post exploitation activities. All right, so the third use case we have suspicious login. So third use case we have suspicious login. So not every compromise look like brute force. So sometimes the login itself just looks weird. For example, login from two countries within a minute, two countries within 1 minute, login at unusual time like 3 a.m., login from unknown device or IP. So these are the suspicious login activities. And why it is matter? So these alert often reveal the phishing attack, and token theft, and then account compromise, and also insider threat. To detect these kind of attack, we can monitor logs like Azure AD log and Office 365 logs and BPN log. Also, you can monitor your Okta log or your Duo log. So these are the key logs you can monitor. And what detection use case you can create. So you can use the sign in logs, and then you can summarize it by first scene, last scene. So you can define a query like this, and this will help you to detect the impossible travel. So if a user login from multiple countries in short time, that's suspicious. And also you can create query for login outside business hours, rare login locations. So these are the use case you can create. And what investigation steps you can check: new IP address, new device, what actions happen after login, and any file downloaded or mailbox changes. So file downloaded or mailbox changes. So what are the real world attack scenario? So here is a common attack chain. So suppose an attacker scan the internet for open RDP. So suppose there is an attacker who scan network and found 3389, the RDP port open. So they brute force using login credential on the system. So brute force, and they eventually get access. So once they inside, they can disable the antivirus, then install the Cobalt Strike. So Cobalt Strike is a very well-known tool used for red teaming activities, and then they can move across the network like privilege escalation. And eventually they deploy the ransomware. So what could stop it? So if your SOC had these alert like multiple failed login attempts, external RDP access, and then suspicious process creation. So if you have these use cases in your SOC, you might stop the attack before ransomwares even run. Some detection engineering tips to make your detection smarter. You can add the enrichment, add enrichment. For example, GeoIP data, TI for reputation, user risk score that you can get using UEBA, and device trust status, whether the device is managed, unmanaged, and what correlation rule you can build for your SOC. So you can create a correlation rule like brute force attack plus success. So if there are too many failed login followed by a success login, so suppose there is 100 failed login and one success login within 5 minutes. So this is a suspicious activity, and you can create a correlation rule for that. And another correlation rule you can create: RDP activity plus admin activity. So RDP login followed by a registry changes or service installation or any scheduled task creation. So you can create a use case for that as well. And the third use case you can create: suspicious login plus data download. So rare login location followed by a large OneDrive download could be a classical data exfiltration attempt. So you can create a use case and monitor in your SOC. And to really master these detection, practice with these tools like atomic red teaming, which is called ART. So practice atomic red teaming, MITRE, Caldera, Splunk, SOC Prime. So you can ever build your own home SOC lab using Splunk for free, Microsoft Sentinel trails, pfSense firewall, and some virtual machines. And that's it of your SOC journey. So today you learned how to detect brute force, RDP, abuse, and suspicious login activity. So these are bread and butter detections for every SOC analyst. And more you practice investigating these patterns, the faster you will move from alert watcher to real defender. So if you are following the 100 days SOC series, please like the video, comment your favorite detection use case, and subscribe so you don't miss the next lesson.